So this is our last lesson on the biggest unit of the year, polynomial, okay? So we covered quite a bit. You're going to have to spend some time looking at the review. The review is already out there, but it's probably the biggest unit. Like I said, it is the biggest unit of the year, so there's a lot of material. But what we want to talk about today are something called Extrema. So Extrema just deals with maximum. It's a fancy word for maximum minimum. You'll do a lot of time focusing on max mins when you get to pre-calculus and if you get to calculus. So we just sort of introduce the concept here. It talks about using the TI calculator to do that. I think I'll show you that on a calculator, but I'm not going to test you over that, okay? It's just, it adds too much to the test to have you to do a TI problem and then a non-TI problem. So we'll be okay without that. You've got enough to worry about on this test without that being there. So the example here, if you were hiking, okay, so suppose you started, let's just say we started right here, okay, and we decided we went up this mountain and we did this, okay, and we ended right here, okay, for some reason to camp. Now, can you look at this and say there was a point in time that I was at my absolute maximum altitude? Yeah, that would be right here. Okay, so that would be my absolute maximum. Can you look at that purple line and say there was a point in time that I was absolute at my lowest altitude of this entire trip? Yeah, you would look right here and you would say that this would be your absolute what? Yeah, your absolute minimum. So your absolute min. Okay, so that's the definition of an absolute max, absolute min. It gets even, I don't know, mathematicians like to get more complicated, but in layman's terms, that's what it is. The highest point is your absolute max, lowest point is your absolute min. We also use terms like this. So what if I drew a circle around this, okay? What if I was just traveling within that circle? Within that circle, is there a spot you could say there was the highest spot of that circle? Yeah, that would be at this peak right here. So that's not an absolute max because it's not the highest point of my journey, but what we call that a relative max. It's a relative max because I can draw a circle, and within that circle, it's the highest spot of the circle, okay? Same thing happens right here. I could draw another circle right here, and is there a spot in that circle that is the lowest point? Yeah, so I could see that that is called a relative min or minimum. So that's all the terminology we're going to be using today is an absolute max, an absolute min, a relative max, and a relative min. Absolute means if I look at the entire journey, it's the highest point or the lowest point. Relative means that I can construct a small area or neighborhood that it is a maximum. So this is, if you look at it right here, that's a relative max. That's a relative max. So all of these are relative maxes. And then all of these are relative minimums, okay, that are right there. So those are all relative mins for the graph. So the basic thing to try to do is to find your absolutes first. Find the absolute max and absolute min if it exists, and then any other max or min would be what variety? After I find the absolutes, they all would be relative. So I can find an absolute max or min, any other max or min would be a relative max or min. So that was just looking at the hike. Now let's transform this to a polynomial. So if I had a polynomial, and keep in mind these polynomials keep on going right here. Let's look at this polynomial. Is the degree of this polynomial even or odd? This is an even polynomial because the end behavior of polynomials that are even is either like this or like this. So I know that's even. Is the leading coefficient of this polynomial positive or negative? It is positive because if it's even and going up, we know that that is a positive leading coefficient. Now we're asked to look at the extrema for this graph. The absolute minimum. Where is the absolute minimum on this graph? Yeah, it's this point right here. So the absolute minimum is negative 0.74, negative 7.4. That is the absolute minimum of this graph. Now, it says there is no absolute maximum. Why is there no absolute maximum? Yeah, it keeps on going up forever. So there is no one point that I could put my finger on and say that's the highest spot of the graph, because the minute I point to a spot and call it the highest spot, the graph keeps going. So there is no absolute maximum. Now, that is that example. But then if you look at it without naming it, what would this point right here, this would be a what? Relative max. This would be a relative min, relative max, and a relative minimum, okay? But there's only one absolute minimum on this graph. Let's look at the next one here. The degree of that, guy, is it even or odd? It is even because its endpoints go down on both ends. The leading coefficient is what kind of number? Negative. And this one has an absolute maximum, but it doesn't have what? Doesn't have an absolute minimum. What's the absolute max here? Yeah, negative 2.47 and 5.1. That is the absolute max, but there is no absolute minimum for this graph. You don't write, you can't write negative infinity as the absolute minimum. That doesn't make sense. Okay, it has to be a finite number. The graph heads toward negative infinity, but there is no absolute minimum in this particular case. So these are things we just been talking about. The absolute minimum is a point that serves on the lowest, it's the lowest part of the graph. You can put your finger on a point and say that's the lowest point. Absolute maximum, you can put your finger on a specific number and say that is the highest point. And then any other max or min has to be a relative max or min. Okay. Now the next thing we want to talk about is you'll spend a lot of time in pre-calc and calculus talking about intervals when a function increases and interval when a function decreases. So what this means is if I travel from left to right on a graph, if my graph is going up, I say that the graph is what? Increasing. If the graph is going down, I say that it is decreasing. See, this is practically teaching itself today. It's set up for remote learning. There we go. So let's take a look at this and let's answer all these questions. Degree of this guy, is it even or odd? This is an odd polynomial. Leading coefficient, positive or negative? It is negative, because odd polynomials, if it's odd positive, it's going to look like this. Odd negative is going to look like this. Okay, so that's what I see the end behavior going up to the right. Now, is there an absolute maximum on this graph? No, there is no absolute maximum. You might be tempted to say that's the absolute maximum. Well, it can't, because they keep going up forever. And don't write infinity as the absolute maximum. There is no absolute maximum. Is there an absolute minimum? Yeah, there's no absolute minimum. What do you think about odd functions? Will odd functions ever have an absolute? No, odd functions are going to either do this or this. So there can never be an absolute max or min on odd function. You'll have absolute max or mins on what kind of function, what kind of polynomials? Only on the even ones. Okay, so now if there are no absolute max or mins, any other max or min, instead of being absolute, it has to be relative. So what is this is a what? Relative min. So there's a relative min at -4, -8. And then what is this point right here? That's a what? Relative max. So there's a relative max at -1, 1.6. And then this is the 0.10. That's also a what? That's a relative min. And the point 3.133 is a what? Relative max. So those are the relative max and the relative mins. Okay. What is the domain of this function? Remember how we did that? The domain is a set of all what? What values? X values. Where do the X values go on this graph? Yeah, from negative infinity to positive infinity. So the domain of this graph is from negative infinity to positive infinity. What is the range of this graph? Yeah, same thing. Negative infinity to positive infinity. And now what's new is we need to figure out the intervals of increase or decrease. Okay. One of the easiest ways to do that is let's just start from left to right. Okay. So as I travel from left to right, okay, is the function, as I travel from left to right, Are the y values going down or are they going up? As I go from left to right, starting over here at negative infinity, what's the graph doing? It's going down. Okay, so the graph is going down. Don't let the what you're basically saying is, suppose I'm right here. If I get to right here, so if I travel from left to right, I was here and now I'm here. Did I go up or did I go down? You went down. Okay, so this graph is decreasing. So it decreases from negative infinity to what point? Negative 4. It's the x values. Okay, so it decreases from negative infinity to negative 4. Okay, so now I'm sitting here at negative 4. I'm going to keep traveling from left to right. As I travel from left to right, what are the y values doing now? As I leave negative 4, what do? They go up. They go up until I get to where? Negative 1. So I've got increase from negative 4 to negative 1. Okay. Now I'm sitting at negative 1. What happens when I leave negative 1? Where do my y values go? Up or down? They go down. So it decreases from negative 1 to where? Yeah, from negative 1 to 1. And then what happens next? From 1 to 3.1. Okay, now I'm sitting at 3.1 and I'm going in that direction. What are my functions? What happens next? Decreases. So what is that interval? Okay, so that's a common, there's a little bit mistaken what it says. It's not 3.1 to negative infinity. It's what? I'm traveling, which axis am I traveling on? Which axis? X or Y? So if I'm sitting here at 3.1, I'm traveling on the x-axis. Where am I going to? I'm going to positive infinity. So it's a common thing to say like, oh, it's 3.1 to negative infinity. No, you travel on the x-axis. So these intervals are all x intervals. So the next interval of decrease is from 3.1 to positive infinity. So these are all x intervals. Okay, so what I mean is, when I look at this, let's erase some of this stuff that I have right here. So the intervals of decrease, it may help you just to have, okay, this is a decrease. This is a decrease. This is a decrease. Okay? This is an increase, and this is an increase. And then all I'm saying are, what are the x intervals? This first interval is negative infinity to negative 4. This interval is negative 1 to 1. This interval is 3 to infinity. And then you see this interval is negative 4 to negative 1, and then 1 to 3.1. So the confusion is these are all x values and x intervals. They're all parentheses. Okay, there are no closed brackets on these intervals. So let's look at another example like that. This function right here, even or odd degree? Even. Coefficient, positive or negative? Negative. Is there an absolute maximum? What is it? There are actually two of them here. So I've got 1.381, and then I've got what, 3.621. Okay, so I'm looking at y values to tell me max and min. So there's the absolute highest point in a y values is 1. If this one had been 1.382, it would be the absolute maximum, and this would be a relative. Okay, is there an absolute minimum here? There are no absolute minimums. Is there a relative maximum? No. Is there a relative minimum? Yeah, what is that? 2.5, yeah, negative 0.563. What are the x-intercepts of this guy? 1, 0, yeah. 2, 0, 3, 0, and 4, 0. What if I were to ask you what's a factor of that polynomial? What's a factor? X minus 1, x minus 2, x minus 3, x minus 4 are all factors of this polynomial. What is the domain of this polynomial? Negative infinity to infinity. The range is the only time you're allowed to travel on the y-axis, okay? To find the range, you travel on the y-axis. What is the lowest y value this graph ever has? Negative infinity. What is the highest y value it ever has? 1. So what is the range? Yeah, negative infinity to 1. And what goes around the 1? A bracket goes around the 1 because 1 is included. We did this last semester. I'm assuming this skill is still there. Is that good assumption, bad assumption? Okay. I think guys are still trying to get weaned off of spring break here. So intervals of increase or decrease. Okay, so let's just highlight it. When this graph starts out, what does this graph, as I travel from left to right, what is the graph doing from, what is this indicating? This is a what? That's an increase. And then what happens next? A decrease. And then what happens? An increase and a decrease. Okay, so when I list these intervals, how many intervals am I going to list? 4. How many increase intervals? 2 and 2. Okay, so the intervals of increase, what is the first interval of increase? Yeah, negative infinity to 1.38. These are all x values. What is the next interval of increase? Yeah, at 2.5 to 3.62. Now the intervals of decrease. What's the first interval of decrease? Yeah, 1.38 to 2.5. And then the next interval is what? Yeah, 3.62 to positive infinity. These are all x values. Okay, you're traveling on the x-axis. So as I go from, the way to think about it is I travel from here to here. Did my y values go up? Yes, they did. As I go from here to here, my y values went down. From here to here, my y values went up. From here to here, my y values are going down. Okay, so that's just how you list intervals of increase or decrease. Let me just take a moment, and I want to just show you that this can be done real easily on the TI Inspire. Maybe not this example, but let me just create one real quick. You'll do this more in calculus and pre-calc, but just to show you, it's real simple. But what I've decided to do on the test is not make you do this, like I said, on the TI Inspire. So let me just graph one real quick and show how that would work. So let's create a graph. If I were to graph something like x cubed minus x squared plus x minus 3. Let me do a different one. Let me change that a little bit. We'll make it a 4th degree. Let me just redo all of this. So, come on. Add a graph. So, x to the 4th minus 2x cubed plus x minus 3. Look at something like this. Okay, so if I had a graph like this, if I needed to figure out what the absolute max and mins are, you have tools on the TI that can do that. One thing that I probably would zoom here, I probably would go ahead and say, let's zoom this in. So let's zoom from, say, x values from maybe -5 to 5. And now what I need to figure out, okay, is there an absolute maximum here? No. So is there an absolute minimum? Yeah, it looks like they're the same, but I'm not sure. So what you would do here is just you would say, analyze graph. What do you think I would do to find the minimum? I would pick minimum, and you just click on either side of that, and it tells you there's a minimum point right there. And then I would click again and say, let's find the other minimum, which is there and there. Okay, so in D, this one has how many absolute minimums? Yeah, these are the same. negative 3.25, negative 3. So it has two absolute minimums. What is this point right here going to be? The one in the middle. A relative maximum. So what would I do to find that relative maximum? I would come over here and say maximum. And I would do that. It would tell me there's the relative maximum right there. Okay. What if I wanted to find the x-intercepts? Okay. I could go menu, analyze graph. What do you think I would do to find the x-intercepts? Which of these choices? Intersections intersection occur, but I would pick a 0 because that's what this is right here. So there's a 0 at -1, 1.0, and then menu analyze graph. The other 0 would be right here at 2.10. Okay. What is a factor of this polynomial? X minus 2.1. What's another factor? X what? Plus 1.1. So those are factors. Is this an even degree polynomial? Yeah. Positive coefficient or negative coefficient? Positive. Okay. So even without you using the TI, I could give you a graph that came from a TI and you could answer the question. So let's do this before we end up here today. Let's look at this example. So here's one that came from the TI. Is that even or an odd function? Even degree. The leading coefficient is what? Positive. Absolute maximum? None. Absolute minimum? Is there an absolute minimum? There are how many of them? 2. They are where? Yeah, 1, 0, and 2, 0. Okay. Is there a relative maximum? Yeah, where's the relative max? Yeah, 1.5, 2. Is there a relative min? No. You would technically be correct if you listed these again as relative min. It's just redundant though, you know, because all a relative means is I could draw a circle and that's the lowest point. Well, you could still do that, but once you've listed it as an absolute min, there's no need to list it again. So you would be mathematically correct if you listed it, but you don't have to do that if it's already listed one time. What are the intervals of increase? So when this function starts out, if I travel left or right, what is it doing when I start out? This is a decrease, and that's a decrease, okay? So what are those intervals? What's that first interval for decrease? Yeah, negative infinity to 1. And then what's the next interval of decrease? Yeah, 1.5 to 2. Now, intervals of increase. Here's an interval of increase, and there's an interval of increase. What's that first interval of increase? Yeah, 1 to 1.5. And then what's the next interval of increase? Yeah, 2 to infinity. What are the x-intercepts? Not everybody at once, but it's 1, 0, 2, 0. What are the factors? X minus 1, X minus 2. Does this one have any multiplicity? Are there any roots with multiplicity here? What does that mean? How would I know graphically that there's a root with multiplicity? It goes through the point, but it doesn't do what? How do we know that there's an even, how do we determine even odd multiplicity? What did it mean with the graph? It's whether or not I cross or do not cross the axis. Okay, it's the homework that I just went around and checked a moment ago. Okay, so am I crossing the axis at this point? No. Am I crossing here? No. So it means that this factor is not only is it x minus 1, but it's x minus 1 squared. This factor is x minus 2 squared. There's a multiplicity of 2. Okay, what's the domain of this function? All polynomials, negative infinity to infinity. What's the range of that function? I travel on the y-axis. What is the smallest y value? Yeah, 0 to infinity is the range, and there's a bracket around that 0 because 0 is included with that particular graph. Okay? So that is it. What I would omit is this information. I'm not going to require you to be able to do this on the TI Inspire. That's sort of a nice to, but you will not be tested on that. Pardon me? Hold on just a second. Let me stop this.